All right, today we are going to be discussing decimal operations investigation 1.1 and 1.2. 1.1 is deciding which operation we need to solve a problem, and 1.2 is going to be how to use estimation with decimals. So we're going to start off by showing how to determine what operation to use when we solve a problem. All right, so first things first. Draymond's mother gives him $20 to take his brother and sister to lunch. They ordered a pizza for $13.95 and 3 drinks that cost $2.25 each. So he has 20, and he's going to order a pizza for $13.95 and 3 drinks that are $2.25 each. All right, so does he have enough money to pay the bill, and which operations should he use to find the cost of the lunch? Well, the first question, does he have enough money to pay the bill? This is simply, what we're going to have to do is add the costs together to find if we're going to have enough. So the first thing we're going to do is we are going to take $13.95, since that's one pizza and that's one cost. We're going to leave it at $13.95. However, the next thing we're going to do is we are going to use multiplication, okay, to figure out what 3 drinks would be if they're $2.25 each, which means we have to take $2.25 and multiply it by 3. So 3 times 5 is 15, write the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. And then 3 times 2 is 6. And then we count the number of decimal places in our problem, and there are 2 decimal places in our problem, so we're going to need 2 decimal places in our product. And so 3 drinks would cost us $6.75. So we're going to add that $6.75 in. And so now we're going to add 5 plus 5 is 10. Carry the 1. 1 plus 9 is 10, plus 7 is 17. Write the 7, carry the 1. Bring the decimal straight down. Carry our 1. 1 plus 3 is 4, plus 6 is 10. Write the 0, carry the 1. 1 plus 1 is 2. So the total of the meal for him and his brother and sister is going to be $20.70. And of course, we're always going to be having tax, but since it didn't say we needed tax in this problem, we're not going to worry about it. So the question is, does he have enough to pay the bill? And the answer to that, since he only has $20, the answer to that is no. He does not have enough. He doesn't have enough. He is 70 OUGH. He is 70 cents short on what he needs. All right. So there are a few things that I used when I was working in this problem to decide what I needed to use. The first was the numbers. I needed to know this number because this is how much he has. I also needed to know that there was 1 pizza for 13, and I needed to know this cost for the drinks, but I also needed to know that they ordered 3 of those. Okay, so and then part of that was this word that said each. If it's $2.25 for 1, and I have 3 of them, then I'm going to use multiplication. So this part right here implies that I needed to multiply to find my total cost for the drinks. Then does he have enough money to pay the bill? Well, in order to figure out if he has enough, we would need to add our costs. So this question right here told me that I should add my cost together. Okay, so for the drinks and the pizza, and then I would need to subtract the total from 20. And even though we didn't really subtract, we know that we can't because I can see that I only have 20 and I need $20.70. So that's one way. All right, so let's try another one. This one says, and I'm going to highlight the numbers and the clue words in my question, that way I can see it. So it says the world record for the women's 400-meter race is 47.6 seconds. The world record for the men's 400-meter race is 43.18 seconds. How much faster is the men's world record than the women's world record? So the first thing I'm going to do is I'm going to highlight the question, because that's going to help me figure out what I need to solve my problem. So how much faster is the men's world record time than the women's? Okay, so we've got a couple of things in there. We've got how much faster. That implies that we're looking for a difference. Okay, so in there, how much faster. Okay, and then we have this than. So we're going to be doing a difference. Okay, so our question implies that we should be using subtraction. Okay, anytime that we are finding a difference, we're going to be subtracting. Now, for the numbers that I need, do we really care about the 400-meter race? No, we don't. What we're really concerned about is the time that it took. So 4.7 and 43.18. So now those are the two numbers I need. We don't need the numbers 400 because that's just telling us what the race was. So I'm going to subtract. And so I'm going to subtract the women's time up here, which would be, excuse me, 47.6. And then I'm going to subtract the men's time from that, so minus 43.18, 43.18. And I'm going to subtract. Now, as I'm subtracting, there's something I need over here. This 47.6 only has a number in the tens place. So I have to add a 0 so that I have something to subtract this 8 from. And then we're going to subtract just like normal. We're going to, first thing, since we have decimals, we're going to bring our decimal down. And then we're going to subtract just like normal. So I can't take 8 from 0, so I have to regroup. So that turns the 6 into 5 and the 0 into a 10. So 10 minus 8 is 2. 5 minus 1 is 4. 7 minus 3 is 4. And then 4 minus 4 is 0. So my answer is 4.42. And then we're talking with seconds. Okay, so then my label would be seconds. Okay, and so my answer for A1 is that the men's time is 4.42 seconds faster. Okay, because their time was shorter. The women took more time to run it. So that's another example of deciding in what we look for. All right, so now we're going to take a look briefly at how to use multiplication, or how to use decimals to estimate or round. So right here, the introduction to problem 1, Draymond ordered a pizza. We're going to go back to our pizza problem with $13.95 and the 3 drinks that cost $2.25. So he could have estimated whether his cost was going to be $20 more. And how we do this is when we estimate by rounding, I want you to think of a hill. Okay? And we're going to use the numbers 1 and 2. So 1 is over here, 2 is over here, and then there would be 0.5 in the middle. So right here would be 1.1, 0.2, 0.3, 0.4, and then we'd have 0.6, 0.7, 0.8, 0.9, whoops, bringing up my email. All right, so when I have this hill here between two numbers, if I started walking up the hill and I only got to about here, it would be easier to go back down the hill. Okay, so if I would have 1.1 and want to round it to the nearest number, I would say that 1.1 would round back to 1 because 1.1 is just 1/10 away from 1. However, if we were walking up our hill and I get to the middle, it would be easier to just go back down the other side to the 2, which is why we say if we are looking at numbers 0 through 4, our number stays. And if we're looking at numbers 5 through 9, we're going to round up. Okay, and that depends upon the place that we're using. So we are going to apply this strategy to the dollar amounts. So we're going to use the rounding, so $13.95. I'm looking, and I want to round this to the nearest whole dollar. So I want to round it to the nearest whole dollar. So that means this place. I'm going to look at the 3 is either going to stay a 3 or it's going to bump up to a 9. So I'm going to look at the 9. The 9 is larger than 5, which means it's closer to the next number than what's below it. So $13.95 would be about $14. Now, my 3 drinks that were $2.25 each, 2.25. Okay, and again, we can do this a couple of different ways, but to get our closest estimation, I'm going to look at the tens place here and use the hundredths place to round. Excuse me. So the 5 tells my 2 to go up, so that would be about 2.3 or $2.30, and then I have 3 of those. So 2.3 times 3 would give us $6.90. Okay, and because this is an estimation, if I added the 14 plus the 6, that's already 20, and it doesn't include this 90 cents. So just using estimation, we could have found that he was going to spend over the $20. So let's take a look at another problem. All right, so when we estimate, we're finding an approximate. So Matt Tatming is shopping for party food, and here's the register. We're going to estimate the bill, and then we're going to go here. So I'm going to round everything to the nearest dollar. Okay, so $2.79 to the nearest dollar, so to the nearest whole dollar amount. The 7 is what's going to change the 2. Okay, so total cost. Okay, if we're estimating the bill, we're trying to find the total for that. So that's going to imply addition. So I'm going to add all of these up. So 2.79, I'm looking at the 7, and the 7 is larger than 5, so it tells the 2 to go up to a 3. Then I'm going to look at $1.99. $1.99 would be about $2. It's only 1 penny away. And again, we're looking at the 1. We're going to change the 1 because the 9 is 1 away from the nearest number, so therefore it tells our 1 to go up to a 2. Now, for the $1.29, again, I'm looking at the 2. The 2 is less than 5, so this 1 here stays a 1, and then everything else becomes a 0. So $1.29 is actually closer to $1 than it is to $2. And the same thing down here with $3.12. We're going to change this 3. This 3 is what's going to be rounded, and I'm going to use the 1 behind it. So the 1 is less than 5. Therefore, my 3 stays at 3, and everything else turns into zeros. Now, on the jalapenos, it wouldn't make much sense to round to the nearest dollar amount and 4 making it go to 0. So we got to pay something for these jalapenos. So what I did here is I just rounded it to $1, knowing that I'm going to have to pay for these jalapenos and that I may not have enough in my rounding up here, oh, there's the bell, to cover that 45 cents. So I went ahead and rounded this up to $1 because I didn't want to make it 0. That wouldn't make much sense. So I found that the estimation should be $10. She's going to spend about $10. So tomorrow when we come to class, we will pick up where we left off. I know this video was long, but we'll see you in class.